In this video, we will investigate heat transfer between ice and water mixture with different concentration. Although they have the same temperature, they have different heat content. This experiment is meant to figure out whether these conditions can drive heat transfer. The experiment will use a styrofoam box as the container to reduce heat transfer to the environment. Two separators are then added to create three compartments. One is made of styrofoam board which acts as a heat insulator, while the other is made of aluminum plate which acts as heat conductor. The middle compartment is filled with ice, and then water at 0 degrees Celsius is added to fill the space. The left and right compartments are filled with water, and then a chunk of ice is added to each of them to keep their temperature at 0 degrees Celsius. A thick paper board is then put on top of the container to reduce heat transfer by convection of surrounding air. I'll show how the experiment is done to detail so anyone can easily replicate it. First step is preparation of ice chunks. Some water has been frozen in the freezer until it turns into ice. The next step is to break the ice into smaller chunks so it can fit into the middle compartment. Add water to the ice container, and mix properly to get ice-water mixture at 0 degrees Celsius. Ten minutes later, the mixture is stirred again to make sure that the temperature is homogeneous. Take some ice chunks and put them into the middle compartment until it's full. Pour remaining water to fill up all the compartments. Take 2 blocks of ice with similar size, and put each into first and third compartments to keep them at 0 degrees Celsius. A thick paper board is then put on top of the container to reduce heat transfer by convection of surrounding air. 40 minutes later, the ice blocks are still there in the left and right compartments, albeit with reduced sizes. Another 35 minutes has passed. The sizes of the ice blocks have been reduced further. Apparently, the one in the right compartment looks smaller. Another 15 minutes has passed. The left compartment still contains ice. Apparently, the ice in the right compartment has completely melted. Let's analyze this. The ice blocks in the container melt by absorbing heat from the environment, which is at room temperature, around 25 degrees Celsius. The heat came from top, side, and bottom of the container. But they are supposed to be identical between first and third compartment. The different results can only be explained by difference in heat transfer with ice-water mixture in second compartment. It means that heat transfer has occurred even when the temperature of every compartment is the same, i.e. 0 degrees Celsius. The net heat transfer between environment and each compartment can be drawn here. The first container only increased its heat content slightly, because some of the heat was easily transferred to second container. The second container increased its heat content from the environment as well as from the other compartments, especially from the first one. The third compartment received heat from the environment in the same amount as first compartment. But since the heat can't be easily transferred to second compartment, the net increase of heat content is larger than the first compartment. It was shown by the time it took to completely melt the ice in the third compartment, which was significantly less than in the first compartment.